predicts Steam game purchasing using user data and game metadata. The goal is to predict whether a user will purchase a specific game on Steam, and this is framed as a binary classification problem. Label 1 means user will purchase the game, and label 0 will be user does not or will not purchase the game. Oh, sorry, just realized I forgot to slideshow this. The input will be the input are game attributes and user behavior. For the game metadata, it includes the price of the game, the genre, sentiments, scores, and the release years and the meta score. For the user behavior, it includes the total playtime, average playtime, the number of game the user own, user genre preferences, distribution, and user consumption level based on the history purchase. For the evaluation matrix, we have the accuracy and the ROC AUC scores. This is able to rank bias above non-bias. Since the data set is in balance, and we care about the ranking equality, not only the accuracy. The baseline will be the linear model, which is the logistics regressions, and also models with less features. And we are using a 80 and 20 percentage for training and test data, and we will navigate sampling to avoid label imbalance and the performance compared against multiple baselines. And here's the dataset I use, and I use these two datasets. Here's the data and analyze. There's a highly skull playtime distribution. You can see that there's a lot of players that play less than 100 hours, and there's also players that plays a huge amount of time. So I take the log transformations to the on the playtime. On the game pricing, most of the game are under $15, and I also observed that the playtime drops as the price increase. Which you can see here, the x-axis will be the price, and you can see that there's not much dots in the side. And the genre popularity, we can see that actions in the adventure and RGB game are the top 4, and most users prefer multiple genre. For the sentiment, most of the game are rated as max and really positive, and sensitive related strongly with the purchase probability, which you can see that the game that rates with really positive have a high user game interaction. That means user own the game. Here's the data process I did. Here's the data frame that contains the user item, which is the user data, and also the item data, which is the game data. And here I am taking the ID column from the metadata and loop over each user and try to generate negative examples. If there's here's the bot list and the not bot list for each user. If there's not enough not bot game to match with the number of bot game for this user, we will just skip this user. And we will randomly sample as many negative as positive for this user. For each sample G that user did not bot, we'll set the label to 0. Here we're just turning the negative rows into data frame and also add the metadata. Here we are adding numbers of unique games per user to the data frame. Here is how I process the genre features for each game. Here for the genre list of each game, there will be a list of string which we might not want our models. We might not want to use this to train our models. Instead, we would like to encode it to a list of 0 and 1s. Here I'm trying to create a one-hot genre features for each of the users and games role. For example, for this game, the genre is action and RPG, and if our genre vocabulary is action, adventure, RPG, the roles of this game will be 101. Here we're fitting a multi-label binarizers onto all the game genres, and this MLB will take a list of genre and of a game and turn into one hot matrix. And right here and then this side will be just naming the genre column. Here's the example of a genre data frame. This one is the first column will be the game ID, and then here will be the one hot matrix. For the sentiment inside the datasets, we will have maybe really positive mix, and all kind of rates. We'll try to. This one is just mapping this rate to the score. And next I am trying to process the user genre preference distribution. Oh, this one is the this one is separate. This graph should be about this code, and this one is just adding the playtime to the data frame. And here will be processing the user genre preference. Here we are joining the user item with game genre, which is for each of the data in user item. We will map the game genres to the game that the user owns. This is export, so we get one row per user and games. And now this line will be counting how many games of each genre a user owns, and then we are converting the count to a percentage. For example, if I have 20 actions genre collective and also 10 RPG genre collective, then 20 plus 10 will be the total genre count. And for the actions preference will be 20 divided by 30 will equal to 0.67. Here's also an example of how this will look like. And here we are trying to implement user consumption features. Here we are just joining the user item with the price, and here we are trying to see how many games are how many expensive game the user owns. This too will be just a list of 0 and 1s, and right here we would just add up this 0 and 1s to see how many percentage of within the total game that the user owns games have the price of greater than or equal to $20, and how many games have the price that greater or equal to $40. And right here the rest of it will be just the price, the more information about the price of the games that the user owns. Here's just more features I added. One is the release years, one is the discount price, and one is the metascore. For the discount price and metascore, I just grab it from the datasets. For the release year, I grab the year from the datasets and use the current year minus the release year to get the game age. For the model formulations, The inputs will be the input X will be the user features and the game features. The user features is just what I talked about previously, and the game features. And also same with the game features. The output will be just 0 and 1s, and the objective will be minimize the prediction error and maximize the ranking quality. The model I use is logistics regressions. The prompt are this is interpretable and is fast to train and is a good baseline. The con will be cannot model non-linear interaction, and it also struggle with complex user preference patterns. For the non-lineage model, I will use random forest models. The prompts are it models non-linear relationships. It handles features interaction automatically and is robust to multi-collinearity. The con R is slower for training and it reduces interpretability. Here's the model code. The X will be just the Y. Sorry, the Y will just be the label, and the X will be all of the features I talked about before. I am dropping this because we are not using it, and then we are using a 80 and 20% for the training and testing. Here's the logistics regressions. This is pretty normal, nothing too much for detail. And this one I'm running for the random forest. This one also the same. This one's for preparing the Y and X. This one's just running the model. And same as this. Next we evaluate our results. The accuracy for the baseline accuracy is 0.83, and our cse158 scores is 0.89. You can see that it just simply saying that if they have a lower price, the user will tend to purchase it. And for the random forest, we have 0.9 for accuracy, and the ROC-ACU scores are 0.96. You can see that the relationship is of the price and the purchase probability is not linear. You can see that there's a rise on between like $60. I'm just guessing that the games that are high budget, high profile, that produced by some major publisher, users are also likely to buy it. Those games are about $60. There's a relationship between the price and the sentiment. But we can see that if the price is low, and the user if the price is low and the sentiment score is high, the user will willing to buy it. And we can see that go to the next slide. We can see that the high features are the sentiment score, the price, and also the genre of the games. This one is the models with the first models, which is the models that contains the playtime, number of games user owns, and user genre preferences, and also the this is a typo. This did not consume the consumption level. The model 2 can include the consumption levels, and model 3 contains a really important features, that is the age year and the release year. If the release year is early, there will be more user willing to buy it. Similar Steam datasets have been widely used in recommendation system research for tasks such as game recommendations, user preference model, and purchase predictions. Early approach including a popularity-based baseline, collaborative filtering method like matrix factorizations, and ambitions personality ranking, and most recent features-based supervised linear models that are combining price, genre, review, sentiments, and user behavior. Our approach following this third direction, linear model caption global trends like price and sentiments, while random forest caption non-lineage interactions and achieve higher prediction performance. The ROC-AUC's value we obtained fall within a typical rank reported in relative studies. And thank you for watching.